senior design presentation for the Perryman Company, where we are building the automated crucible flange cleaning device. My name is Zachary Miller.
My name is Mark Bidoli.
I'm Jake McCune.
And I'm Bryce Nill.
Let's get into it.
So getting into a little background about our company, Perryman Company is a titanium manufacturer in Washington, PA, where they actually melt the titanium themselves. So they have two types of furnaces there, electron beam furnaces, and what we're working with, a vacuum arc remelting furnace. Specifically in the furnace, we are working with their copper crucible. One important thing with this crucible is it has to be properly cleaned in between each use. That way it ensures a proper clean, and so no oxidation or residue can get into the melt while it's underway. Currently, they have an automated cleaning device to clean the inside of the crucible, just not the flange. So they have an operator with an angle grinder and a cut brush manually cleaning the flange, which is unsafe due to it being on a rotating table while it's cleaning, which adds a bunch of pinch points.
So what were the objectives of our project? So our project objectives were to design the automated cleaning device for the top flange of the crucible that's used in the VAR process, and to allow for safe and unobstructed loading of the crucible onto the cleaning table. These objectives led us into our problem statement, which is to design an automated machine to safely clean a crucible flange.
All right, so moving on to concept generation and selection, we made 48 complete concepts with this process, and this involves individual sketching and collaborative sketching.
So one of the biggest challenges in this project was cleaning the inside of this O-ring groove that was mentioned by Bryce earlier. We had to do an iterative design process to figure out what brushes would work and what brushes would get the job done.
Moving into our final design, as I said earlier, the cleaning table that they're currently using sprays water on the crucible, so it's a very wet and dirty environment. So we wanted to make sure that all of our components could withstand that. So we chose mainly aluminum and stainless steel. That way there's no rust and the components will hold up. Another thing we wanted to do was make it very modular and easy to manufacture and assemble. That way it's easy to see any failures further on down the line.
All right, so another key part to this design was the analysis. We did analysis on each critical component in the design, which involved using ANSYS Workbench, performing hand calculations to determine maximum stress and fatigue, and we determined a factor of safety for each component. This example here is the beam support mount, which bears the weight of the beam during cleaning. For this analysis and all the other analysis, we assumed worst case scenario conditions, which is that the maximum motor torque was being applied to the mount. And for this analysis, we got a factor of safety of 3.62 for a 10-year lifespan.
Okay, so also moving into our analysis, we found the runtime for each component. One of our specifications was that the device needed to operate under 5 minutes for the total clean. And as you can see here, the total time that we got from all the moving components is around 212 seconds, which gets out to 3 minutes and 32 seconds.
The main deliverable for the end of our project was complete drawing files of all the components that belong in our final design. So a total of 24 machine shop ready drawings were made. As you can see, this is an example of one here. Every member of the team contributed to these drawings, and at the end of the project, they were sent to the sponsor. Thank you for watching.